Hello students, let us continue the MCQ series. Here, in the first question, they are asking the largest number of molecules are present in, and the options which are given, they are in gram. So let us first convert all the given options in mole, and from mole we can calculate the number of molecules. So let us see the first option. In the first option, they have given 34 gram of water. So students, how to calculate the number of moles? Number of moles of water is equal to given mass, that is 34, divided by the molar mass of water, that is 18 gram. And so this answer you will get as 1.88 mole. Similarly, the number of moles of carbon dioxide will be given mass divided by molar mass. So this will give you 0.6. For number of moles of methanol, it will be given mass divided by molar mass of methanol is 32. So this will give you a value of 1.4. Similarly, for the last one, that is number of moles of N2O5, given mass is 54 divided by its molar mass, that is 108. So this will give you the number of moles as 0.5. Students, as the number of moles will increase, the number of molecules will also increase, and therefore the number of moles are maximum in the first option, that is 1.88, and therefore the answer is first option. Let's see the next question. The number of gram molecules of oxygen in 6.02 into 10 raised to 24 carbon monoxide molecule is. Now here students, if you see the question which is given, they are given in the raised power of 10 raised to 24, and therefore it's a hint that you can take help from Avogadro number. So what will be your standard equation, student? 6.022 into 10 raised to 23 molecules will correspond to 1 mole of carbon monoxide. Therefore, for 6.02 into 10 raised to 24 carbon monoxide molecules, it will be how many moles? Simply by cross multiplication, you get 6.02 into 10 raised to 24 divided by 6.022 into 10 raised to 23. So if you calculate this, you will get an answer of 10. So this is for oxygen molecule. And they are asking for oxygen here in carbon monoxide. So therefore, atomicity of oxygen is, here atomicity of oxygen is 2, and therefore it will be 10 divided by 2, that is 5 gram mole of oxygen. So your answer here is second option. See the next question. If 3.01 into 10 raised to 20 molecules are removed from 98 milligram of H2SO4, then the number of moles of H2SO4 left are. Students, in this particular question, they are asking you how many moles of H2SO4 are left in the reaction. So what we need to calculate here, the initial moles and the number of moles that we have removed from the reaction mixture, then you will get the total moles of H2SO4 left. So let us see how to calculate this. First, you know that the molar mass of H2SO4 is 98 gram. Right student, here the mass which is given is 98 milligram. So convert that to gram. You know that 1 gram corresponds to 1000 milligram. Therefore, 98 milligram will correspond to how much? So you will get, it will be 98 into 10 raised to minus 3 gram. So you have converted the given mass also in gram. Now you can calculate the number of moles. So number of moles of H2SO4, what we have used initially, that will be equal to 98 into 10 raised to minus 3 gram. This is the given mass divided by molar mass, that is 98. So you will get 10 raised to minus 3 moles. You can write this moles as, because you have to do the further calculation, you can write it as 0.001 mole. So this you have calculated the initial number of moles. Now let us see how many moles you have removed from the reaction mixture. So for that, how many they are asking for? 3.01 into 10 raised to 20 molecules are removed. If you see the word here molecules, we can take help of Avogadro number. So let us see how many moles they have removed. So students, the second calculation is 6.022 into 10 raised to 23 corresponds to 1 mole. Right? So for the given mass, that is 3.01 into 10 raised to 20, it will be how many moles? So by cross multiplication, you get 3.01 into 10 raised to 20 divided by 6.022 into 10 raised to 23. So what you get here is 0.5 into 10 raised to minus 3. How you can write this, student? You can write this value as 0.0005 moles. Those moles what you have calculated, they are the removed moles. You have initial moles, you have removed moles. So what are left will be equal to, so H2SO4 moles remain is equal to the initial moles, that is 0.001 minus the removed, so 0.005. So the answer here will be 0.5 into 10 raised to minus 3 moles. So let us check the answer. So the answer here is second option, 0.5 into 10 raised to minus 3. Let's see the next question. In this question, If Na is the Avogadro number, then the number of valence electrons in 4.2 gram of the nitride ions is. So students, first let us calculate the number of valence electrons. Here in the question they are asking for a valence electron. So nitrogen atomic number is 7. So its electronic configuration is 2 and 5. So there are 5 electrons in its valence shell, but they have given the nitride. So therefore in N3 minus it will be 5 plus the negative charge you have to add here. So that will give you 8 electrons. So there are total 8 valence electron. So let us calculate in 4.2 gram of the nitride ion. So the formula here is you have to calculate the number of valence electrons in 4.2 gram of nitride ion is equal to the given weight divided by the atomic weight of that particular ion multiplied by Avogadro number multiplied by number of valence electrons. Now students, here I have not used the value of Avogadro number because if you see the options, they have kept that Avogadro number as Na. So no need to use that for the calculation. So let us substitute the values here. How much is the given mass is 4.2. Atomic weight of nitrogen is 14 into Na multiplied by 8. Now if you calculate this, you will get 2.4 Na. So the answer here is first option. Let us see the next question. Here in this question, they have given calculate maximum mass of calcium chloride produced when 2.4 into 10 raised to 24 atoms of calcium is taken with 96 liter of chlorine gas at 380 mm pressure and 27 degrees Celsius. R value is given and Avogadro number is given. So let us first write what all things are given, students. Here they have given the pressure, and the pressure what they have given is 380 mm. You know that 1 atm is equal to 760 mm of Hg. And therefore, I need to convert this to ATM because if you see the R value, it is given in ATM. So therefore, pressure will be equal to 380 divided by 760. Now I have converted this to mm of Hg or ATM. So this is the first value we have written. R they have given 0.08. Next, they have given the volume, that is 96 liter, and temperature is 300 Kelvin. Now you have P, you have V, you have R and T. So from this you can calculate N by using ideal gas equation. So from ideal gas equation, PV is equal to nRT. Therefore, N is equal to, let us rearrange the equation. It will be PV by RT. Let us substitute the values here. So you get the number of moles. Student, this number of moles there will be calculated for chlorine because they have given this data for chlorine. So number of moles of chlorine is equal to 380 divided by 760, that is your pressure, multiplied by 96 divided by 0.08 multiplied by 300. If you calculate this, simple it is calculation, this will give you 0.5 and answer here will be 2 moles. So those 2 moles are of chlorine gas. I got the first mole of chlorine. Now let us calculate the number of atoms of calcium which are involved in the reaction. So the second calculation will be number of atoms of calcium that are used in the reaction. So for this, let us see the particular atoms which they are given of calcium, that is 2.4 into 10 raised to 24. By seeing this value, what you can take help of is Avogadro number. So let us use the equation 6.022 into 10 raised to 23 molecules of Avogadro number, that is this much, will correspond to 1 atom of calcium. Therefore, in given mass, that is 2.4 into 10 raised to 24, how many atoms of calcium are present? Right, student? If you cross multiply this, what you will get 2.4 into 10 raised to 24 divided by 6.022 into 10 raised to 23. So this will give you 4 atoms. 4 atoms of calcium. Now by taking help of 2 moles of chlorine and 4 atoms of calcium, now let us write the equation. So what will be the third calculation, student? The equation will be calcium plus chlorine will give you calcium chloride. How many atoms of calcium are involved from the calculation is 4. Chlorine moles are 2 here. Now if you see the reaction, they are asking the question, you have to calculate the maximum mass of calcium chloride. To calculate the maximum mass of calcium chloride, I must know the number of moles of calcium chloride here. So students, if you see this can act here, there are 4 atoms or 4 moles and there are 2 moles. So here this is limiting reagent while this is the excess reagent, and therefore number of moles of the product will be formed will be decided by the limiting reagent. So here it will be 2 moles. Now let us calculate the molar mass of calcium chloride. So it will be 40 plus 71. So this total comes out to be 111 gram. I got the molar mass. I know the number of moles, so I can calculate the given mass. So moles of calcium chloride is equal to given mass divided by molar mass of calcium chloride. So how many moles they have given, student? From the calculation we have calculated is 2. So that is equal to given mass divided by the molar mass, that is 111. So your answer for given mass will be equal to 222 gram. So according to this, your answer will be fourth option. Right, students? Please do comment if you want some specific MCQs or some specific chapters. And if you find this video helpful, please do like this video, share it with your friends, and please subscribe to get more such videos. Thank you, students.